So this is part 2 of the video explaining the calculations for measuring the thickness of a hair with a laser diffraction lab. Alright, so we've shown how we can use W sine theta sub n is equal to n times the wavelength lambda. Now, okay, we're going to look at this big triangle here. The idea is that this big triangle here, there's theta, one of the sides is L, one of the sides is y1, is similar, it's a similar triangle to this small triangle over here that has W as its as one of the sides, and so it's the same theta. So now if we look at this triangle right here, we can say this. We can say that excuse me, fix this there. Okay, because one of the properties of tangent is that it's equal to opposite over adjacent. Opposite is y, in this case y1, over L. We also know that okay, W sine theta is equal to 1 times the wavelength, n is equal to 1, or sine of theta 1 is equal to, I'm not going to write the 1 anymore, lambda over W. We also know, this is from trigonometry, tangent of theta is equal to sine of theta over cosine of theta. And because theta is really, really small, we can say that cosine of theta is really, really close to 1. What that means is now we can say tangent of theta 1, which is equal to y1 over L, is approximately equal to sine of theta 1, which is equal to lambda over W. Okay, that all makes sense so far? So basically, at this point, what we can say is y1 over L is basically equal to lambda over W. Now that's really nice, because now we can say this. We rearrange this, solve for W. Remember, that's the thickness of the hair. Make sure I do this right. L times lambda over y1. That would be the thickness of the hair that we get. So now to calculate the thickness of the hair that we get from measuring the distance from the middle of the bright spot to the middle of the first dark spot, that is y1, and L, that's the distance from the laser to the wall. Knowing the wavelength of the laser, plug these numbers in, we get the thickness of the laser. Thickness of the hair. We can do this also. Give us the subscript 1. That's for the first dark spot. For the second dark spot, same hair. We can say W2 is equal to 2. That's our n coming into play. Remember, it was 1 over here, so we didn't write it. Times L times lambda over y2, which you measured. All you have to do to find the thickness of the hair 2 times for one hair is to find W1, distance from the laser to the wall, that's L, wavelength of the laser, remember, just to remind you, the wavelength is 633 nanometers. Whoops. Which we're going to write as that. You can convert it however you want to. L depends what units you measured L in. Probably want L and Y in the same units. That'll give us the thickness of our hair. Just watch your units on this one, you'll be okay. Okay, so what you guys are going to do is you're going to do this calculation for all 5 hairs. So that means you're going to get 10 W's. W1 and W2 for hair 1, W1 and W2 for hair 2, hair 3, hair 4, and hair 5. Once you get those 10 W's, you're going to find the mean, find the standard deviation, and that's it.